Hello and welcome to another KIE Live session. And today I'm excited because we are doing it in a different time. So we have different folks with us here today. So welcome everyone. Let me know where are you at right now? So I'm based in Brazil, so it's currently almost midnight, and I'm really glad that I am here with you guys because I have an expert already on the backstage, and we are going to talk about Drools, which is our rule engine, and we are actually going to do a deep dive on Drools. So we'll see how we can troubleshoot it, how we can find possible issues and also possible bottlenecks on the performance. And the guy who's here with us today is working with Drools for many, many, many years. I think more than 8. I can ask him. Uh, or even 10. Let me bring him on board. Toshiya, welcome. Thank you for accepting the invite.
Hi, this is Toshiya. Thank you for inviting me.
Sure. Toshiya, so how long have you been working with Drools already?
Yes, almost 10 years.
Almost
I
10.
started as a technical support engineer, and then I worked for various middleware products, including Drools and jBPM or application servers. And now I moved to Drools Core engineering team.
Ooh, very nice. So you are actually creating new stuff for Drools and fixing bugs directly. So that is your main role right now.
Oh, yeah.
Yoo, congratulations, really nice. So let me tell something to the folks who are watching us right now. The cool thing to be here right now live is that you can actually bring your questions to Toshiya. So as he moves on with the presentation, feel free to ask questions and I will bring it to him, okay? Toshiya, so I will start sharing your screen right now, okay?
Okay, please.
Okay, your screen is now here. Great presentation, Toshiya.
Excuse me, I couldn't hear.
You can start.
Okay, I
Go
can
for
start.
it.
Okay.
Yes.
Okay, I start. Okay, so hello. Today I'm going to talk about Drools troubleshooting. So agenda is unexpected rule firing, property reactivity, debugging spreadsheet, control the flow of rule execution, and performance issues. This slide and demo projects can be found in my GitHub repository here. So feel free to download. These projects run with Drools 7.52, but actually 7.53 has just been released yesterday. So I'm sorry that I didn't have time to update it, but when you develop, maintain a project, please use the latest version as possible. Okay, so now a warm-up quiz. Okay, here is a rule about order processing. You see that if item is guitar, you get some discount. If order is high price, you get also some discount. So we can guess that if we purchase expensive guitar, I will finally get 600 discounts. So what's wrong? So let's run the test. Oh no, so this is looping. Okay, so what I want to do if you hit a strange issue, I recommend to use event listener. So here, debug listener, which is built-in listeners. So you can see various information from the engine. Okay, let's run it again.
Toshiya, and these listeners are available out of the box already in the engine?
Yes, it's the built-in event
Okay, awesome.
listeners. But
Okay.
also you can implement your own custom event listener. so that you can tailor the output. So here it's a little bit verbose, but you can find lots of information. So you see that the object inserted, what's inserted is order object. And here is activation. Activation means a rule is matched. So the rule, guitar discount is matched, and high price discount rule is also matched. Next, then the rule is going to be fired. So guitar discount rule will be fired, and object is updated. And then the rule activation is going to be finished. Then next is the key point. So again, we see activation created for guitar discount. So it means that the guitar discount rules activate itself. That's a reason of the loop. Okay, so what we can do? So we have very good attribute, which is called no loop. Okay, so this attribute prevent from looping caused by itself. Okay. Okay. Do you think it will fix the issue? No. Unfortunately, this time we get loop alternately. Guitar discount, high price discount, guitar discount, high price discount. That's bad. So no loop is only prevents looping by itself. So what we want to hear is lock on active. Lock on active blocks any loop regardless the origin of the evaluation. So let's see. Okay, so finally we get the right result. So one guitar discount, one high price discount, and we get the 600 discount amount. So recap the use event listener to understand what's going on. So we have built-in event listeners, but also you can write your own custom listeners. You can find the event name and then what rule is activated or what is firing and what object is updated. And we have two attributes to prevent loop. No loop is for to prevent a loop which is triggered by the rule itself. Lock on active is once the rule is fired, it's no longer fired regardless of the origin of revaluation. So in many cases, you like to use lock on active, I think. Okay, so the next topic, but a little bit related, this is property reactivity. So you see this rule. Do you think it's pretty looks similar to the previous rule? So previous rule had this about discount condition. So in a constraint that says it has a discount upper limit, but this time only check the item guitar. Do you think this rule loops? Let's see. Okay, this time it doesn't loop. Why? So I'm going to explain. So why this doesn't loop? Because Drools engine analyzes rules. and it knows this rule only tests item property. And this rule fired, and then it updates discount property, but the item property is not changed. So Drools engine understands we don't need to evaluate this rule again. This is the property reactivity. So comparing the previous example, as I said, it had a discount constraint. So discount has to be less than 2,000. In this case, we updated the discount property, and we check this route want to check the discount value, so it needs a re-evaluation. So it causes a loop. Then what about if we don't use field constraints? So for example, we have a method which is called check special item, and then it's black box. So the engine doesn't know which property is tested. In this case, it triggers loop again. Okay, but we have a workaround. So if you add watch annotation, you can let the engine know that this rule checks only item. So it will prevent the looping. Since Drools 7, property reactivity is enabled by default. So be careful when you migrate from Drools 6. Property reactivity is good for performance, and you can write rules more naturally. So basically, we really recommend to use this. But if you hit a strange behavior and if you doubt property reactivity, temporarily you can disable it so you can confirm the difference. So, this issue is caused by the property reactivity or not. All right. And next topic is debugging spreadsheet. Again, this is a quiz. What's wrong with this spreadsheet? But this is an unfair quiz because it's very difficult to see the defect just by looking. So let's try the demo again. So I run this spreadsheet. Okay, I get error message. Okay, you see that it says no viable alternative at input. Well, I'm sorry that this message is not very user-friendly. So, but I can tell you, this means there is a wrong word or character here. Here means you can see that 10 and 15. It means line number and column number. But this is line number and column number of generated DRL. So it's not about the line or column of a spreadsheet. So just by looking spreadsheet, you cannot find the root cause. So you need to know that the spreadsheet generates DRLs. So you can check the generated DRLs. How to? So let's see here. This is a system property, Drools dump directory. So if you set the directory, configure this system property, generated DLLs will be dumped into this directory. Also, there's one more way to check the generated DLL. Here is a spreadsheet compiler. So if you use this spreadsheet compiler, you can get the DLL as a string. So you can just simply check the DLL string. Now, let's have a look at the generated DRL here. So you can see the DRL, this is very simple. So one row is turns into one rule, and next row is another rule. And remember the error message that it was line 10 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 15 here. Here is the problem. This is double quotation. It still looks no problem, but you need to believe in the error message. So this double
No, this
quotation.
was so tricky. This is not fair.
Yeah, this is not fair. So correct double quote is this, and the wrong one is this. But this is not joke example. Actually, I have seen this issue a few times. So this is not artificial.
Awesome. Great tip. Great tip. Thank you.
Yeah, this is not artificial issue because Microsoft Excel or LibreOffice may convert your character automatically. So sometimes this plain double quotation can be turned into this one. So it's up to the configuration of the tool. So please, you need to check the configuration. I think there's a way to suppress such conversion.
But the fix needs to be made inside the spreadsheet, correct?
Yeah, this.
Yeah.
Yes, inside spreadsheet. So now I want to fix this. Okay. Fixed. And run again. Okay. This time it works. Hello world and goodbye career world. So here is a recap. So firstly, no viable alternative input means that a wrong word or character here. And this line number and column number, so you need to check the generated DLLs. Also, you need to notice that the tab is one character. So you need to count it differently, maybe. And how to check the DRS? There are two ways. So system property Drools dump there or spreadsheet compiler. Okay, the next topic. So how to control the flow of rules. So DLL is a declarative language. So basically, you don't need to worry about order of rule execution. However, of course, sometimes you want to control the flow of execution. So for example, you have hundreds of rules and it had three groups: first evaluation group, second evaluation group, and the final evaluation group. And you want to execute these rules in this order. You can do it in several approaches. So I don't say which is the best, but I just want to share. So firstly, split into multiple key bases. If you can logically split these rules, it's just fine. You can split key base. So if your key base is very large, it's going to be hard to maintain or difficult to debug. So if you split into smaller key bases, it's good for maintenance and debugging. And next, salience. So it's very convenient. You just give the number, so salience. But too much use of it could be messy. And agenda group, this is a standard approach. Probably in many cases, you want to use this one. And rule flow group. Rule flow group is actually almost same as agenda group internally. However, it has a good combination with BPMN because BPMN has rule task which supports rule flow group. So you can visualize the rule flow. And finally, control fact. Today, I demonstrate control fact pattern. This is not a special syntax, just introducing a fact to control the flow. Let's see. So first I want to share the rule. So it's similar to the previous slide. Now we have 3 groups. Okay, so we want to execute with this order. But so if I simply execute this rule, here I get rule 1.1 is fired, rule 2.1 is fired, rule 3.1 is fired, it's okay. But now rule 1.2 is fired. I don't want to fire this rule 1.2, which belongs to the first category. So I want to introduce control fact. Control fact is just a plain Pojo object, and then you can use any name. Here, I just use control fact, but you can use different name. Also, you can use any property. Here, I use stage. So at first, it is stage's first evaluation. And I rewrite the rule with using control fact. So it really looks simple. So if stage is first evaluation, it can be executed. So it depends on the stage. So you can see this can be evaluated or not. And then I want to insert the control fact and fire. Now see here, 1.1 is fired, 2.1 is fired, 3.1 is fired, 3.2 is fired. So rules are executed in the expected order. What good thing in control fact is it's flexible. So you can add any property in the control fact class so that you can have various conditions to control the flow. But again, I don't say this is the best approach. You can choose these approaches which fit well for you. Okay, now this may be the most interesting topic for you, performance issues. Firstly, I list up common practices about performance problem. So firstly, please set up your benchmark for repeatable testing. Repeatable is important. And also, it's easy to run. It's important. Because if you make some changes and then you want to more quickly check the effect, so you can see it's improved or performance get bad or so. And there is a framework which is called JMH. This is recommended for fine tuning. It is really good framework so that we Drools team use basically JMH for benchmarking. If you don't know about this, it's worth checking. And second, enable GC logging. GC is really common issue, so it may be easily you can solve the issue by just increasing the heap memory. And next, narrow down the bottleneck. It's also important. So not just saying my application is slow, but you need to break down and which part is slow. Rule execution itself is slow, or key server payload marshalling is slow, or other application logic, or external system access in right-hand side, like accessing to database or web services. So Typically you can narrow down it by adding some logging. Assuming you confirm that the Drools is slow, okay, let's see. So sometimes we hear that the first response is slow. So it's a common claim. So it's true that the key-based loading is slow. So the solution is please try executable model. Executable model is a new way of running the engine, and then it generates Java classes at Kja build time. So key-based loading time is significantly improved. Just add dependency Drools model compiler to your POM file and then build a Kja. Actually, Kogito uses executable model, so we think this is a next standard way to execute the Drools engine. And other than key-based loading, you may think that the first fire or rules invocation is slow, and it gradually gets faster. If you run again, it's going to be faster, but especially fast invocation is slow. It has various reasons because engine has various internal caches internally, so in various level. And also, env constraint is slow at first time. And then env constraint turns into a Java class dynamically, so it will get faster. Also, generally, Java has JVM zipping, so it will get gradually faster. So it has various factors. And now the solution, again, try executable model because executable model doesn't have env-related performance issues. Also, the other approach is warming up. So for example, create a dummy key session and insert dummy facts into a key session and fire. It will cause some populating caching, so it will improve your next actual invocation. Such improvement depends on your rules. If your application is sensitive about the first response, it's worth trying. And then other than first response, now I'm going to talk about the execution overall. So if you have slowness, I'm going to explain some of best practices. So watch out for cross product. So you see that if you insert 1,000 customer facts and 1,000 product facts, it's going to be a 1 million combination, and it will affect the next evaluation. It's huge. And list the most restrictive rule conditions first. So number of evaluation will be reduced if you change the conditions order, and it will be faster in the later phase of the rule evaluation. Also use simple field constraints as possible, not eval. So because simple field constraints has more chance of internal engine optimization. Eval don't have any optimization, so please do not use eval. So please use the simple constraint. However, I can understand that reviewing lots of rules is hard, it's tough. So Drools metric is a new module. It helps your analysis. I'm going to demonstrate it. Well, in order to use Drools metric, you need to do three things like adding dependency, Drools metric, to your POM file, and set log level trace for metric log utils class, and set system property Drools metric logger enabled true. Threshold is optional. You can change it, but the default value is 500 500 microseconds. Note that the Drools metric is not for production environment, so please use it in your test environment to analyze a bottleneck. Well, here is the rule. Okay, so you may notice that this rule is badly written, but imagine that you have thousands of rules. It would be difficult to find a suspicious rule just by reviewing. So I'm going to run the test. Here is the firstly, here is the output of dump associated rules ready. So this is the code from here. This one, ready dump associated rules ready. It dumps list of nodes, okay, and then with associated rules. So you can find the associated rules from a problematic constraint or node. And please check the total elapsed time. It's 2 seconds. It's slow, and you find that the trace level logging, they are count from Drools metric. So now we are going to find the bottleneck. So we will check the evaluation count and elapsed microseconds. So among these logs, this one, accumulate node is significant. So eval count is almost 5 million, and elapsed micro is almost 2 seconds. It is very slow. And let's go back to the dump associated rules ready output. Here is the accumulate node 8. It is associated with the rule named collect expensive orders combination. So this is the rule. So you can find the rule even if you have thousands of rules. Now we can going to review this rule, but also we will have some hint from the logging again. So if you have unusually large eval counts, you will check the previous node. So here is the join node. So you can find that the join is here, and it means that this accumulate is evaluated for all O1, O2 combinations. This is wrong. This is not what we expected, because this accumulate is used to calculate the max price of a customer. So we want to calculate just right after the customer. Okay, then run it again. Now see, elapsed time is 500 milliseconds, so it's a big improvement, okay? And now accumulate counts first, and the eval count is elapsed time is smaller. So this is good, but also we can have more improvement. So let's see if we have another bottleneck. So let's see this join node. It has eval count is 100,000. It's still significant. Also, we have eval condition node. It takes long time. Okay, so let's look at the rule again. So here, O1 get price greater than max price minus 50. So this is very restrictive condition. So please remind the best practice that I said that most restrictive condition should be placed earlier. And also we want to avoid eval. Rather we should use simple field constraint. So the fix will be like this. Now I change the code to check the price here. It will reduce the number of combination. So let's try. Okay, now we get some more improvement. Probably more than 30% improvement. So we have less evaluation count. So this is how to use Drools metric. To recap, to find bottleneck node from check the Drools metric logs. So you can find node name and how many times the condition is evaluated and how many times elapsed. And also use rated dumper dump associated rule rated. This method shows which rule is associated with the problematic node so that you can find the rule to be reviewed. Then fix rules following the best practices, just like I demonstrated. For detailed explanation, please read this URL. Please visit this URL. This page explains the same thing what I demonstrated in detail. Okay, so I finished today's topics, and then I just want to share about the community. So we have Zulip chat, and please join the Zulip chat with Drools stream. Also, we have forum and Google groups. So Drools users and Drools setup. We really appreciate your participation and questions and contribution. Thank you.
Very good. Awesome presentation you had there, Toshiya. Congratulations. I really like the tips that you share. And not only like how to troubleshoot, but actually implementation details. So thank you for that. I have shared the link to your repo. It's on the chat for those who didn't see it. I will also have put this on the description of the video. And you will also find the slide deck available on Speaker Deck. So all these slide decks are usually available here. And Toshiya's slide deck is on his GitHub and also here on the Speaker Deck community. So feel free to check there. And Toshiya, once again, thank you a lot for your knowledge sharing today.
Thank you very much. I hope you enjoyed.
Yes, thank you, Toshiya. And for those who were here, I'm really glad that you have enjoyed it, and see you on the next session. Bye-bye.